Hi there, my name is Marina Miletich. The log mean temperature difference is a quantitative measure of the difference in temperature between the streams at both ends of the heat exchanger. Let's look at an example of a co-current flow fixed head shell and tube heat exchanger. If one end of the heat exchanger is designated A and the other end is B, we can calculate the difference between the two stream temperatures at each end. The difference in temperature between the two streams at end A is delta T sub A. The difference in temperature between the two streams at the other end is delta T sub B. Notice this heat exchanger is co-current flow, so for this type of heat exchanger, delta T sub A is the difference between two inlet streams, and delta T sub B is the difference between two outlet streams, but this is not a set rule. If we were to consider a countercurrent heat exchanger such as this one, which has a shell side flow going the opposite direction, the temperature difference at end A is still delta T sub A, and the temperature difference at the other end is still delta T sub B. The only difference is that these delta T's now represent the difference between an outlet and inlet temperature. Once we've calculated delta T sub A and delta T sub B, we can then use this formula to determine the log mean temperature difference. Here are some things to keep in mind when using log mean temperature difference. Sometimes ChemCAD or Aspen will calculate log mean temperature difference for you, but I recommend checking their work to be sure, since I've seen these programs miscalculate this value. In doing so, when calculating log mean temperature difference, delta T should be the hot temperature minus the cold temperature for both delta T calculations, so as to avoid using negative numbers. Lastly, heuristics in some textbooks state that a log mean temperature difference of over 100 degrees centigrade should be avoided because it usually requires a more expensive heat exchanger. Accommodating a large temperature difference between streams requires special heat exchangers that can facilitate expansion and contraction without fracturing or leaking. A few examples of heat exchangers that are designed for such conditions include floating head, bayonet, U-tube, spiral plate, and others. It's important to calculate log mean temperature difference to see if a special design is needed,